In this video, we are looking at the remainder and factor theorems. And here we have a polynomial, f of x, you divide it by x minus k. Then it says the remainder is the same as substituting k into the polynomial. And here we are going to use an example to illustrate this. So here we have a polynomial, and this is being divided by x plus 3. So here, let me walk you through the process. So this is the f of x is x to power 4 minus 8x cubed plus 11x minus 6. And xk is represented by x plus 3, because that's what we are dividing by. So that means k is equals to negative 3, which I get by equating x plus 3 equal to 0. So I get x is equals to negative 3. Now, here, we need to find the remainder. And I'm going to use two ways to find the remainder, and you're going to see the answer is the same. So I'm going to use synthetic substitution. And here, I just need to know the coefficients. So I look at the polynomial. So the coefficient here is 1 and negative 8. And I see there is no x squared. So that's going to be, so there is no x squared. So I need to put 0 there, and then 11, and then minus 6, and then, or negative 6. And then here I'm going to put negative 3. So this is going to be 1. This is going to be negative 3. This is going to be negative 11. So this is going to be 33 positive, 33. So this is going to be negative 99. And here I'm left with negative 88 times 3. That gives me 264. And when I add, I get 258. So that's the remainder, 258. And here I can also use direct substitution. So, and remember, it says the remainder is the same as plugging in k. We can use synthetic or direct substitution. So here I can do f of negative 3, which is equals to negative 3 raised to power 4 minus 8, negative 3 raised to power 3 plus 11 raised to power multiplied by negative 3, and then minus 6. And if you put this, if you work this out, you'll get 258. So you can see here, if I can summarize this, if you are given a polynomial, you divide by a factor, it's the same as plugging in the 0 of that function into the polynomial. That will give you the remainder. So here we are supposed to get f of minus 3. And how do we do that? So I just do use synthetic division or synthetic substitution. So here I have 1. So I'm missing 2 to the power 4. 2. Then 7. I'm missing x. So negative 11. And so this is going to be 1. Negative 3. So it's negative 3. So this is 9. So that becomes 7. So negative 21. So this becomes negative 14. And this becomes 42. So 42 times 3. So here we get 126, and that's going to be minus. So negative 1, 3, so negative 1, 3, 7, and that's the remainder. So the next one here is factor theorem. And what do we know here? A polynomial f of x has a factor even only if the remainder is 0. Or if you plug in k, you get 0. So here we are given determine x minus 3 is a factor of that. Okay, again here we're going to use synthetic substitution. So here I'm going to do 2 and negative 3, negative 5, negative 12, and this is going to be positive 3. So this is 2, this is 6, so that's 3, 9, this is 4, and that's going to be 12. So the remainder is 0. And since the remainder is 0, then we can say yes, it's a factor. And you can also use direct substitution to do the same thing. Okay, determine if x plus 6 is a factor of, so we do the same thing, 3, 14, negative 28, negative 24, and here we are going to use negative 6, so that's 3, negative 18, so negative 4, so that's be 24, so negative 24, oh, sorry, not negative 24, but negative 4, and that will be 24, so 0, the remainder is 0, so we say yes, it's a factor. Why? Because f of minus 6 is equals to 0, or the remainder is 0. Okay, determine whether x minus 4 is a factor, and if yes, use synthetic division to find all the other factors. Okay, so we're going to, so here we do the same thing. So this is going to be 4, so this is going to be 1, negative 8, and 4, and 48. So this is 1, 4 times 1 is 4, so negative 4. And that's going to be 4 times negative 4, which is negative 16. So that's going to be negative 12. So 48 negative, so we get 0. So we know it's a factor. So we are told to use synthetic division. We are already using it. So here we're going to write this as an equation. So this as an equation is the same as, so x squared, I'm going 1 degree down, minus 4x minus 12. So I just need to factor this one out. I need two numbers I can multiply to get negative 12 when I add them to get negative 6. So this is going to be x minus 6 and x plus 2. And those are the factors. So now I can write all the factors. Okay, so f of x is going to equal the first factor which I was given, which was x minus 4. And then the ones I just got, which are x minus 6 and x plus 2. There we go. Okay, so here we are given that factor, show that x minus 7 is a factor. Then we factor the polynomial completely. So here I have 2, negative 9, minus 32, minus 21. And here we're going to write 7. So this is 2, 14. So that's going to be 5, 35. That's going to be 3, so 21. So that becomes 0. So here we're going to say, yes, we have shown that. And then the next thing is to write the equation down. So this is 2x squared plus 5x plus 3. So here, let's use synthetic, not box method, to factor this one out. So here I have 2x squared, and this is 3. So two numbers I can multiply to get 6, and I add them to get 5. So that will be going to be 2x and 3x. So once I factor, this becomes 2x. What's common here? 3 is common. X is common there. 1 is common. So what are the factors? So the factors are, so f of x is equals to, let me start with the one which was given, x minus 7. And then the other factors we got are x plus 1 and 2x plus 3. And that is the answer. And that's how to do it.